everyone, this is Hardhik. I'm a graduate student from CSU and we are working on Biochar toilet. Coming to the problem and the goal designs. So initially we have observed that there are like few places in the world that we still uses open drainage system, which is like not unsanitary and also environment hazard too, because of the open fecal matter of human or any animal waste lying around on the road or sideways would make attract harmful pathogens, which is also affecting the human health who are like living surroundment, and also will affect the water system over there and others. So for that, we wanted to develop a low cost and electrically powered toilet system in which the fecal matter which we excrete would be turning into biochar and can be used further as like fertilizers for and also can also be used as a bio coal too. So coming to how we designed it is we want to design it in a controlled chamber where both temperature and pressure is controlled, where because biochurring happens at a low environment, low oxygen environment with higher pressure in it. Yes. So for this, we want to create, as I mentioned, oxygen-free environment in which we can control both the pressure and the temperature. And we need to increase the temperatures a bit slowly, slowly in order to have the organic material to be charred properly both the sides. So for that, what we designed is we have taken a pressure cooker and we have sealed up with a few pressure gaugers and also like pressure valves for it to control the to control the pressure in the chamber. And also we have a few thermocouple sensors which are attached to the chamber to control the heat. And we have also controlled the hot plate using a solid state relay which can turn on and off based on the heat of the chamber. Yes. So our first goal questions are like, can we detect the dryness and can we have the pressure in the chamber safe? Because handling with high pressure environment is always a hazard. And can we automate the heating process and can we like turn off the heating when the pressure is detected? Yeah. So as I mentioned, this is the whole temperature setup we use, where you can see we have a pressure cooker with a pressure manual gauge reading, which we also have a pressure sensor attached at the end of the wall, which can read and translate the temperature to the ESP32 board module, which can then read the pressures in the environment and at the same time can also help us in achieving our goal. So what it does actually is it dries the material in the seal chamber, and when it detects there is no moisture content in the chamber, it assume, and then the heating is still increasing and there is no change in the pressure. It detects the temperature detects the sample as dried. So this is the first test we initially did. We did a number of tests actually. The first test would be using a loaf of bread, and these are the results we got. And there's one thing which we observed is due to the samples as being very small, we were not able to detect the dryness of the sample, and also there's a lot of soot residual which has been formed at the top of the lid. So these are like two next goals which we are going to tackle. So this, yeah, and heading over to Peter.
Hey guys. So what we're going to work on next is we're developing an induction system with a bentonite clay and magnetite blend. Our hopes is to use the bentonite clay to wake up the moisture, and the magnetite embedded in that will heat up using induction coils. So we have a more thorough heating of the sample and better control, and ideally make it more efficient. We're currently modifying a Hawkins Classic pressure cooker, and we intend to bend our own coils and make some of our own modifications to the fittings as needed. But we're hoping that this will be really successful.